Hello and welcome everybody in this new video from AB Travel Joy Technology, where we're going to discuss about the basic principles of a diesel engine. So how does a diesel engine works? First, we're going to use this model. This is a gasoline engine or a Otto engine. And if you know how this works, then we're going to make the step to a diesel engine. And after this movie, you know what the difference is between a gasoline engine, like a Otto engine, and the diesel engine. So let's get started with how this gasoline or Otto engine works. Okay, let's check out how this gasoline or Otto engine works. Here we can see an air filter. This is the inlet port with the throttle inside. This is an inlet valve. This is the exhaust valve with the exhaust port and exhaust system. This we call a piston. The piston is inside a cylinder. So this is the cylinder, this is the piston. This is a connecting rod, and the connecting rod connects the piston to the crankshaft. We can see that the piston is going up and down, and because of this construction, the crankshaft will rotate. This is the same rotation of your wheels. Yes, there is a transmission system between and a differential and whatever, but it is the same rotating energy that's coming from the engine, from the crankshaft, going to the wheels. Okay, so here you can see that the piston is going up and down. From the top dead center to the bottom dead center, so this is the top dead center, this is the bottom dead center, we call this a stroke. Okay, let's see what's happening inside this gasoline or Otto engine. When the piston is going down, the first stroke, we call it an inlet stroke. That means that the inlet valve opens because the space inside the cylinder is getting bigger and bigger and bigger because the piston is going down. That means there will be a vacuum because the space is getting bigger. The same system as our lungs is, if we inhale like this, is our lungs getting bigger, there's a vacuum, so air is getting into our lungs. The same system is here in the cylinder. The space is getting bigger and bigger and bigger. There's more volume inside the cylinder. That means that air will get inside the engine through the inlet valve inside the cylinder. This air is mixed with gasoline, so there is a mixture of gasoline and air inside the cylinder. After the inlet stroke, there will be a compression stroke. Both valves are closed right now, so the complete cylinder is closed, and that means that we're going to compress the air and gasoline mixture inside the cylinder. When it's almost on the top dead center, there will be a spark from a spark plug inside the cylinder, and it ignites the mixture of gas and oxygen. That means there will be an explosion, and the explosion is the same as a lot of heat in a really short time. That means that the air expands because of the heat, and this expanding air pushes down the piston. So this is the stroke that makes the energy. So after the stroke, there will be a exhaust stroke. That means that the piston is going up, 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 up. The exhaust valve is open, so all the exhaust gases, the burned gases, can get out through an open exhaust valve to the exhaust system. Okay, let's check out how this engine runs constantly. So the piston is going down, the volume inside the cylinder is getting bigger, so there will be a vacuum. The vacuum, there will be air mixture with gasoline sucked inside of the cylinder. So this is the inlet stroke. there will be a compression stroke. Both valves are closed, so I compress the air mixture with gasoline inside of the cylinder. Just a little bit before the top dead center, there will be a ignition by the spark plug. It ignites the mixture of gasoline and air inside of the cylinder. There will be an explosion. An explosion means that the air inside the cylinder expands really fast because of all the heat. It's coming free from the explosion, so it pushes down the piston. That means that this is the power stroke, and after the power stroke we can see a exhaust valve opens, so all the burn gases inside of the cylinder can get out through a open exhaust valve to the exhaust system. After this, the complete party starts all over again. There will be a inlet stroke and a compression stroke, a power stroke, a exhaust stroke, and all over again. A inlet stroke, compression stroke, power stroke, exhaust stroke, inlet, compression, power, exhaust, inlet, compression, power, exhaust, etc., etc. You can see here all the strokes you can see inside of this engine. That means that the piston is going up and down 4 times because there are 4 strokes, and 4 strokes of the piston means 2 rotation of the crankshaft. And what I said before, this is the same rotation as your wheels, but there is a transmission between and a differential, etc., etc., but it is the same rotating energy from the crankshaft going to your wheels. Okay. From here on, we're going to start with the diesel engine. A diesel engine, the principles are the same, so I will use the same model, but because the crankshaft is the same, and the connecting rod and your piston and your in and exhaust valves, etc., etc., the principle is the same. But now we're going to see what's the difference between a gasoline, a Otto engine, and a diesel engine. Okay, there are some differences. You can see I changed a little bit this model. There is no carburetor in the inlet port anymore, because a diesel engine normally can suck as much as air inside the engine as it wants. The system is still the same, like the piston is going down, air is getting sucked in the cylinder, but now it's not a mixture of diesel and air, but it's just clean air without any kind of fuel inside. So we compress now the air, it will be compressed, and when the air is compressed, you can see this space on top of the piston. In a diesel engine, this space is a lot smaller, really a lot smaller. So when this space is smaller, I compress the air more inside a diesel engine than I do in a regular gasoline engine. And when we compress air, there will be more heat. So when we compress air, compressing air generates heat. And because of the smaller space above the piston, we call this the compression space. Because a diesel engine, this space is less, it is a smaller space, it means there will be more heat by compression of air. And this heat is that much that this is the moment that we spray diesel inside of this cylinder under a high pressure. What you see here, this is a diesel injector, and this diesel injector sprays diesel inside of the cylinder. But because all the heat inside the cylinder, because of compressing air, it means that the diesel is sprayed inside the cylinder, explodes or ignites or burns by itself. So when I spray diesel inside the cylinder after the compression stroke, the diesel will burn by itself. That means that there will be a lot of heat by this explosion and expanding air because of the heat in a short time, means that now there will be the power stroke, the same power stroke as the gasoline engine, but now the power stroke is generated by burning diesel. There is no spark plug what ignites the mixture. The mixture ignites by itself because of the high pressure, and the high pressure is the same as a high temperature. And this high temperature makes the diesel burn by itself. So now we have the same 4 strokes. There will be a exhaust stroke, and after the exhaust stroke there will be a inlet stroke, but it's only a mixture, or not a mixture, it's only air. It's getting sucked inside of the cylinder, just air. We compress, we compress, we compress. There is heat generated now by compression, and because I compress a lot more in a diesel engine than I do in a regular gasoline or auto engine, it means there will be more heat. So compression is more heat, compression is more heat, more heat. And now there is so much heat inside of the cylinder on top of the piston that I spray under high pressure a little bit of diesel inside of the cylinder. And because it's so warm inside, the diesel ignites by itself. So the diesel will burn. There is a lot of heat in a short time, so it presses down the piston. There will be my power stroke, and I have this exhaust stroke. So the difference between a gasoline engine is there will be no throttle inside of the inlet port. It can suck as much air inside as it wants. And there will be no ignition system. There is no spark plugs, there is no ignition coil or whatever. There is no ignition system on the diesel engine because the diesel ignites by itself because of high pressure and generated heat inside of the cylinder. Okie dokie. The modern injection systems of these diesel engines is a common rail injection system. In this video I'm only going to talk about this common rail system because it's the most modern system. Here we can see this diesel injector. This diesel injector is mounted inside of the cylinder head, and it sprays directly the gasoline inside of the cylinder. So it sprays the diesel inside of the cylinder. And this happens under really high pressure. Like old school engines, this pressure was maybe 350 bars to 500 bars, but a common rail system, in a common rail system like you can see here, pressure, a diesel pressure inside, this is the common rail, can be 1000 bars or maybe sometimes 1500 bars, and sometimes in extreme circumstances it can be 2000 bars. So this is a really extremely high pressure. And this extremely high pressure makes that when we spray the diesel inside the cylinder, that this is a good spray. The diesel can vaporize fast in this warm cylinder, and only vaporized diesel burns. So the high pressure makes a good spray and a good vaporizing inside of the cylinder. So this is a common rail diesel injector. There is a electronic connection. The computer, the ECU computer, gives a signal to this common rail injector, and when it gets a signal, it opens and it sprays diesel inside. So this is a high pressure line from the common rail. This is a common rail sensor. It measures the pressure inside of the common rail, and this is the high pressure pump. And the high pressure pump generates a pressure from 7 to 10 bars to this 1000 or 1500 bars. So What you can see here is a regular fuel pump. This fuel pump sucks out the diesel fuel from the tank to the high pressure pump, and this is the high pressure pump. And you can see here a plunger inside the cylinder. You can see it's going up and down, and this plunger compresses here on this spot, compresses diesel under really high pressure, and it compresses and it compresses. This high compressed diesel pressure, like 1000 bars, is going through this line inside this common rail. On this common rail there is mounted the high pressure line going to the diesel injector, and the diesel injector injects the diesel inside of the cylinder. So this is a common rail system, and because of this high pressure we can generate more power than we did like 20 or 30 years ago. It is a cleaner burning, so it's better for the environment, and it takes less fuel. So there are a lot of positive things about the common rail system. So this is the basic principle of the common rail system. Everything inside of this common rail system makes this high pressure, and it's very you have to handle it with care. If you work on this system, take care that you use gloves and everything is clean, because a little bit of sand or dust is catastrophic inside of this high pressure pump. So now you can see a little bit how a diesel engine works, but also how we can spray the diesel inside of the cylinder. The pressure inside of a cylinder by a diesel engine can be like 35, 40 or 45 bars. That's regular. In a regular gasoline engine, just this Otto engine, it is 12 bars to a maximum of 18 bars. So this is the really big difference by this diesel engine, where the diesel burns by itself inside of the cylinder because of a higher compression pressure. That's the huge difference between a regular gasoline engine and a diesel engine. Okie dokie, this is the end of the film about how a diesel engine works, or actually the difference between a regular Otto or gasoline engine with the spark plugs and the ignition system and this diesel engine. I hope after this movie you learned the difference between these engines. Last thing I want to discuss about is the compression pressure at the end of the compression stroke. On a diesel engine, it's more or less, because there are a lot of different types of diesel engine, but more or less it's 30 to 50 bars. And in a Otto engine, it's more or less 10 to 20 bars. So this 30 to 50 bars, this generates the heat by compressing air. And this heat we need for the diesel to ignite itself inside of the cylinder. So in this diesel engine, with a cold start, we need glow plugs. These are electronic plugs inside of the cylinder, or inside of the cylinder head actually, and they run by electricity from the battery. They heat up to 600 to 1000 degrees. They heat up the cylinder, and so you can start the engine, and there is enough heat to burn the diesel inside of the cylinder. After a while, the computer of the motor management system will shut off the glow plugs, because there is not a lot of or enough heat inside of the cylinder for igniting the diesel by itself. So this is the difference between the gasoline engine and the diesel engine. I hope you like this movie. I hope you learned something about this movie. If you liked it, please give it a thumbs up on our YouTube channel, AB Travel Joy Technology. And the next video is about filling your own propane tank. Why to fill it by yourself or not? Is it safe or not? So this is what we're going to discuss in the new video. Thanks for watching now, and see you soon. Bye.